and, or sorry, I've got to take the exponents and add them together. So 1 plus negative 2/5, that's just 3/5. So I bring down my y, and its new power is 3/5. And then you just write them all next to each other again. Negative 8, x, his power is 11/4. Y, his power is 3/5. That one was a big one. That one you have to know to separate them, that you can only combine them if they have the same base. So look for the ones that have the same base. All right, this one. This one's not a big deal. We've got these two on top being multiplied. When you multiply, you add powers. So I'm going to take 5/3 plus negative 1/2. That would be, boop, 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 calculator says 7/6. So our top now becomes x to the 7/6 divided by x to the 2/3. Now we're dividing exponents, which means we've got to take the powers and subtract 7/6 minus 2/3. Calculator, boop, boop, boop. That equals 1/6. No, 3/6. Sorry, 7/6 minus 2/3. That becomes 3/6, or 1/2. So final answer, x, bring that new power over, and that's it. That's the answer right there. Okay, so the next properties that I was talking about that we didn't discuss for that last problem are my sharing property. Now these sharing properties, all they say is when you've got some stuff inside the parentheses, some stuff being multiplied, not just one single thing anymore, like the one where there was one base and two powers, like right here. This is when there's multiple things inside that set of parentheses, like this right here. There's a 4 and an x squared. Now this 4 technically has its own power. So what happens for this rule is that 4, everybody gets to be raised to the 4th power. So it would be 4 to the 4th power, and then x squared to the 4th power. This one's easy, 4 to the 4th. You could boop, 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 calculator that out. Whoops, that's not even right. That's a big one. We'll just leave it as 4 to the 4th. That's fine. And now I've got 1 base, 2 powers. That means I multiply these two together, which means this becomes x to the 8th. So it's the sharing property. If you're in a group and everybody gets raised to the 4th power, then everybody gets to have that 4th power added to it. So this 3 goes here, this 3 goes here. It becomes 5 to the 3rd times 4, who's already got a power, and you give him the power also. Now again, this guy's got 2 powers, so we're going to multiply them together. So his new power is 3/4. So our answer is 5 to the 3rd times 4 to the 3/4 power. Okay, and then it also works with when you're dividing, right? If you've got a fraction inside, then you still share. So this 5 is going to go both to the x and the y. So now it's x to the 5th divided by y to the 5th. Okay, same thing over here. The top thing, 5 to the 1/3, oh, I hate that box, is going to get squared, and then also the 4 in the bottom gets to be squared. Okay, we've got 2 powers here. That means we're going to multiply them together. That's going to be 2/3. That's the new power on 5. So 5 to the 2/3. And in the bottom is just 4 squared. You could write 16. All I'm concerned about on this one is that you know how to apply those powers. Okay, so here's the trick to these. If you see somebody inside has a power already, if there's already a power, then use parentheses when you bring that that new power in. Like here, these parentheses I used, that was to help me remember to multiply the 2 and the 4, not add them together, which is a common mistake. Okay, here's some examples. Let's share some stuff inside. I need to share this to here and to here. Okay, he's already got a power, so I'm going to put parentheses around him to apply that other power. Same thing with the 4. I'm going to give him his own power. We're going to multiply powers. 1/2 times 2, that's just 1. So 6 now has a power of 1. And then I don't know what those stupid boxes are for, just so you know, and I don't know how to stop them from coming. So apologize. 1/3 times 2, that's 2/3. So 4's new power is 2/3. Now we don't need to write the 1 on the 6, so it's just this. And no, you do not multiply the 6 and the 4 together. This 4 to the 2/3, that's an exponent, so you'd have to apply that before the multiplication. But we're just practicing these rules, so it's okay. Okay, this one. I've got 2 things inside here. I've got a 2 and an x to the 1/2. So both of them are going to get the power. 2 to the 4th. X already has a power, so I'm going to throw those parentheses on there and raise it to the 4th power. 2 is just going to stay 2 to the 4th, or you could multiply it out and it becomes 16. This guy, though, has 2 powers, so I'm going to multiply those 2 things together. That's 4 over 2, or 2. So x's new power is squared. Forgot to circle that guy. Psst, don't forget to circle. All right, next one. We're just sharing again. 3x to the negative 1/4. There's no power outside here. So there's no sharing. It's just going to say 3x to the negative 1/4. But this guy does have a power to share, so it becomes 5 squared. I'm leaving parentheses just to keep it separate from this one on the left. And then we have x to the negative 3/2, which got squared also. Okay, again, nothing to do with the 3x to the negative 1/4 yet. 5 squared, we can call that 25. And then this x, we've got an x, and there's 2 powers. So we're going to multiply those together. Negative 3/2 times 2. That becomes negative 6 over 2, or negative 3. So this guy now becomes x to the negative 3. Now, we've applied the sharing property and gave everybody the power, but now we've got 2 separate sets of exponents that we need to join together. So this is like that previous problem we did. The numbers can be multiplied out. And since x has both of these have x's as a base, then we're going to combine those together as well. Okay, let's see, 3 times 25, that's 75. And then these are 2 exponents being multiplied together, so now we add the powers. Negative 1/4 plus negative 3. Let's see. That is going to be negative 13/4. Make sure we keep that part separate. So now it becomes x to the negative 13/4. Now wait a minute. We're not supposed to have those negative powers right there, right? So one more thing to do. That guy has to go down in the bottom because he's got a negative power. 75 has its own power, so it's not going anywhere. And this becomes x to the 13 over 4, but now that power is positive. All right, let's talk about this one over here. That was a doozy. That was a good question. Woohoo! Okay, we've got a fraction inside. All it means is now we have to share with everybody. So it was x to the 5th on the top. That gets raised to the 1/5 power. On the bottom is y to the 5th. He gets a 1/5 power. Each one of these, it's 2 powers right next to each other. So we're going to multiply those out. 5 times 1/5. That is 5 over 5, or 1. So on top, it's going to become x to the 1 over, now y's got the same numbers we're multiplying, so it's also going to be y to the 1. But you don't have to write those ones if you don't want to. So that would be our answer. All right. Let's do this one. Let's go with dark purple. This looks like a doozy too, huh? Okay, where do we start? Well, this power outside's got to be shared with everybody. Every single thing in this problem gets a 1/2 on it. So splitting each one up, I've got 4 to the 1/2, x to the 5/3 to the 1/2, and then this y here to the 1/2 over, in the bottom, the 5 gets the 1/2, and x to the negative 1/3 will also be taken to the 1/2. Now 4 to the 1/2 and 5 to the 1/2, you can't simplify those. Fractional powers, and they don't have the same base. So they're going to stay that way. These x's, though, we've got, these guys can be multiplied together, one base with 2 powers. So 5 over 3 times 1/2, that will be 5 over 6. So that new power, this guy, we've got 4 to the 1/2, x to the 5/6. Whoops, let me put that in green so you can see where it came from. 5/6. Then we've got this y to the 1/2 chilling. There's nothing we can do there. Over, now we've got another set of powers, right? Negative 1/3 and the 1/2 have to be multiplied together. Negative 1/3 times 1/2 becomes negative 1/6. That's the new power for the x on the bottom. So still got that 5 to the 1/2, but that x now on the bottom has a power of 1/6, negative 1/6. Okay, I'm looking at that, and there's a whole lot going on there, huh? Seems like a lot. So I'm actually going to split it up into pieces so that I can look at each individual set together. I've got the 4 to the 1/2 and the 5 to the 1/2. Nothing I can do there, so I'm going to leave those alone. Then I've got x to the 5 over 6 divided by x to the negative 1/6. And then we've got this y to the 1/2 just chilling, waiting to be part of the answer. The only thing that we can change is these x's right here. Right? They're the same base and they're dividing. So I'm going to take those powers, the 5 over 6 minus negative 1 over 6. Be very careful with those. Minus a negative will become plus. That's 6 over 6 or 1. So we can now change that set of x's right there to x to the 1. So 4 to the 1/2. On bottom is 5 to the 1/2. Then now we've got x, but his new power is technically 1. You wouldn't normally have to write that, but I'm writing it so you can see where it came from. And then we've still got this y guy hanging out here to the 1/2 power. Nothing else can be simplified, so that would be your final answer right there.